Hello, I'm Haris Pedusis. I'm sports science third year student at Uclan Cyprus.
Hello, I'm Yoros Aresti. I'm a third year student at the sports science at Uclan University Cyprus.
Hello, my name is Dr. Zaharia. I'm a third year student at Sports and Exercise Science at Uclan Cyprus.
Hello, my name is Christos Pedusis. I'm a third year student of sports and exercise science at Uclan Cyprus.
Hello, I'm Firas Kornaris. I'm a third year student of sports and exercise science at Uclan Cyprus.
Hello, my name is Vo2max. I'm a third year of sport and exercise science.
So today we are doing for VO2 test with our client. Welcome, I'm Haris. Okay, first of all, I'm gonna collect some information. It's general information. What's your first name?
Arash.
Arash. Your last name? Vo2max. What's your age?
18 years old.
18 years old. Date of your birth?
4 April 1998.
What kind of sports do you do?
Football.
Football. So your placing position is?
Center back.
Center back. Okay. Here, as I will show you right now, is the informed consent. This data that we will collect today is only for our university research. You have the chance to read it. If you are, you have to sign it. It's about general, if your family has any history of any kind of problem. I think you are elite athlete, so you don't have any kind of problem. Okay.
Okay. Before we begin, we need to take your basic alphametric measurements. We need your weight. You have to pick up your shoes and socks, please. Okay, step on and take these, your hand and open it a bit, squeeze it. Keep it there. Okay, you can put it down now. And come here. Come here, please. Head back. Okay, it's important for these measurements to find your relative value VO2 when the test begins, and also to input your data in the computer. Yeah, put them on, please.
Before we start the test, we have to do calibration. We have to calibrate the sensors for measuring the change of gases. In the bottle, there is oxygen and CO2. Now we'll calibrate the sensors of CO2 and oxygen that we measure. The procedure will take 3 or 4 minutes.
Right. So after we finish the calibration, we start now with the heart rate monitor. We make sure that the heart rate monitor is wet. So can you take off your jacket, please? Put up your t-shirt. So So we put this here, click this from one side to the other side, we put next to the heart, have better contact. Now the heart motor is ready. So now we're ready to put the mask, for the just mask the head. We click these two on, now the other two down here. Okay. So now we have to adjust this to have air. Okay, and I think now it's okay.
After the calibration of the sensors, you have to calibrate the amount of air that the machine measures. For this, we have a turbine that measures 3 liters of air in every in and out push. Nothing is red, we continue with the test.
Okay, now to start the test. The test starts at warm-up phase for 3 minutes. Okay, the inclination will be at 3% and will be constant until the end of the test. At the warm-up, you start with 4.8 kilometers per hour speed, and it's going to rise every 1 minute for 1.2 kilometers per hour. Then, after the 3 minutes, you're going to enter the exercise phase, where again the speed is going to go up 1.2 kilometers per hour every 2 minutes, though, in contrast with the warm-up phase. Okay. In order to start the test, again, you have to just, while you run, when you cannot go anymore, hold here, you jump at the sides, okay? Right.
Okay. However, this machine, this kind of test, it's a golden standard for aerobic exercise and aerobic testing. The type of this machine is measured breath by breath. Also, this machine can measure the metabolic rate, the RMR, and that's it. And the minute ventilation of the personnel. Now we continue with the test. Okay. So first of all, to start the test, we have to input our data that we collect as the weight and height. However, this machine can measure the lactate acid in the blood with the spots of the lactate threshold. And okay. So now the test is ready. Pasto. Okay, now we measure our our client's heart rate, the resting one. Now the machine is measure the breath, but the test is not started yet. In order the test to start, we need to press start from here, and the treadmill will start elevating 3% and start running. However, at the warm-up phase, every 1 minute, the treadmill will increase the speed. And at the main part of the test, every 2 minutes, the test will increase the speed.
Okay. Can you come here, please? Okay. As you can see from the left-hand side of this chart, there's two lines. There's a red one and a blue one. The red one indicates the oxygen uptake of the athlete, and the other one, the carbon dioxide. It's common sense as the test will increase, the oxygen uptake will also increase, so the athlete can keep to the tempo of the test. But however, there will be a time where the carbon dioxide production will be higher than the oxygen uptake, and this is called respiratory compensation, and also the athlete will hyperventilate also.
So, on the thermographic design, you have to see that the red line is the ventilation, and the blue line is the heart rate.
Just follow the pace, okay? Let's do our warm-up.
Here you can see the VO2 oxygen consumption. Millimeters per kilogram is the relative VO2, and the other is the pulmonary ventilation, that the amount of air that used in 1 minute.
So we can see here, we can also see the absolute value of VO2 measured, which is in liters per minute. And now, as we can see, it's 0.81. We can also see the R value, which is the CO2 production divided by the O2, and it indicates whether the athlete is working on fats or carbohydrate, what is burning for energy. When it's 0.7, the athlete is totally burning fats, and when it reaches 1, then the athlete moves to only using carbohydrates. In between, it's a ratio between the both. The athlete uses both to burn and get energy from them.
Moreover, another important thing is the recovery phase. The recovery phase will show us the ability of the body to come back to the normal heart rate. Also, we can see if you come closer. Here, when we're gonna finish the test, we'll push the recovery phase and don't push the stop button. However, at the end, we can see from the recovery phase that the ability of the body to sustain, to resist and filter the lactic acid. However, we need to speak with the clients, with the athletes. How we feel, Arash? Okay? Perfect. We will continue. Nice. Continue our exercise, please. Just relax and the pace follow. Nice. However, okay, so as you can see now, we can see the heart rate of our client, the time and the speed,
as well as the stage of that we are reaching right now. Nice, keep going.
However, at the first graph, at the left, come closer please. We can see a linearity of the VO2 and the VCO2. This linearity, it will end with a peak increase and will shape a V, like a V, the English V. However, at that point, it will be the ventilatory threshold 1. It means that the lactic acid reach more than 2 millimole in the blood. However, will continue to increase linearity.
At the point the body cannot clear the lactic acid, the muscles start to fatigue for the linearity.
Because now, during this test, we're not measuring lactic acid through blood. We're not going to pierce the athlete. We can measure the lactic acid in the body, in the blood, from the gas exchanges in the body that happen during the procedure. Okay. As my colleague here said, at a point, the athlete will reach a point where the linearity of the slope, the line will break, and it will create a V slope. There is the lactate threshold one, is a ventilatory threshold 1, which is called lactate threshold. The lactate starts to being more than enough for the body to filter, and the acidity is more than it's more than 2.2 millimoles in the blood.
As we can see from this point now, the R value, we're using both a mixture of fat and carbohydrates. When it reaches 1, we're going to use mostly carbohydrates, but still at the point we're using a mixture of both fats and carbohydrates.
Here for relative values of VO2, the resting relative values is 3.5 milliliters per kilogram per minute, and for pulmonary ventilation, for rest is 6 to 10 liters per minute, and at maximal exercise about 100 to 170 liters per minute.
However, there is factors that influence the Vo2max, which is the genetics, the gender, the body size, the type of training, these factors will influence the VO2 max of any individual.
Start to clear out, and you can see the ventilatory threshold 1 and 2. As you can see, the lactate threshold is here when the linearity breaks and starts to go up in fast. And here we can see that the CO2 production is started to be in a ratio 1:1 with the oxygen production. So the oxygen uptake. So now the athlete is starting to fatigue and get into the anaerobic zone where he burns only fat. As you can see here, the R value also is indicating that with being 1.05.
tests will be finished when the client feels dizzy. You must push the emergency stop button, or if he feels any pain, you must stop. And when the respiratory exchange ratio is above 1.1, you can see that he reached his Vo2max. And when his heart rate is above 90% of his predicted heart rate max.
Go a little bit faster. Come on, push yourself, we need to reach the limit. Nice boy. Come on. Get a nice pace.
So as we can see now, our athlete is nearly at his best performance, let's say. So now it's the exactly point to encourage him. So there is many ways to encourage him. We have to say to him, shout to him, any kind of help that he can reach his maximum level. Come, let's go. 2 minutes. Come on. Okay. That's it.
100 base.
Stay there.
Now we see the treadmill elevated.
Now it's the recovery phase. Here, the athlete, if he feels very uncomfortable, they can take off the mask. But in purpose of good results of the test, we need to keep the mask on the athlete to take the recovery phase. The athletes, in order to continue working on the treadmill, should the treadmill increase the speed until 4.8, and however the athlete will work 2 minutes until his heart rate will be less than 114 beats per minute. However, the athletes will continue right now working, and as we see here, we can see, come further please, or at the we can see here that the VO2
And the VCO2.
and the VCO2 had that cross the X1. That means the athlete couldn't absorb more oxygen and he exchanged more carbon dioxide. However, that's why the athletes couldn't go further.
As we can see there, we can record the recovery phase as well. We can see the oxygen, the VCO2 and the VO2 dropping, and the machine collecting the data for us. We also get the recovery heart rate later on, which we need to see. As we can see, the heart rate also dropped to 147. We're going to give the athlete another half minute to 1 minute to relax a little more. And we're going to continue the results analysis later on.
However, the athlete is still working. Relax, that's it, good job.
Very good. You did well.
And at the end of the test, we will help the athlete to improve his aerobic performance. How we will show you later in the video at the end when we will done from the recovery phase and we will go past to filter and find the Vo2max, the lactic threshold 1, the RC respiratory compensation, and with that things we can find the way there is many research that give us that they can use the speeds of lactic threshold and RC to improve the aerobic performance or the heart rate too. Okay, now it's time to stop the athletes. That's it.
After this, we're also going to put him through some static stretching as well.
Gloves are needed, take off the mask, yes. Too much saliva is there to protect ourselves and the athlete from any diseases. Okay. Well done, Arash. Now we need to filter the results and print the report. We also need to clean the masks and sterilize everything.
Now we are gonna, because the machine it's measured breath by breath and it's hundreds breathing measure and will be a mess in order to find the VO2 the Vo2max. We need to filtering and averaging to 10%. Here we can filter anything, okay. However, we continue to find exactly manually the Vo2max, and we will try to find level. That's it. Is there the peak? I will continue to find the lactic threshold and the respiratory compensation. This machine, it's very good. They can find exactly where is the lactic threshold and respiratory compensation. However, it will be good to retest it again. Okay, it's a clear review here. We continue. Here we need to find the report. Here is the report and we printed it in order to see clear what's happened. How you feel? Good. Good. However, here, Arash, you did 16 minutes at the treadmill. It's quite good. How old you are? 18 years old, yeah? Yes. Okay, that's it. Okay. We can see the speeds of the lactate threshold, that is 10.8. The speed of respiratory compensation 13.2, and the peak that it was at the end. However, with that too, Arash can go to give this report to his fitness coach in order to train him in that speed to improve his aerobic performance.
Okay. Yeah, as we can see from the results that Chris just said, from the lactic threshold to the respiratory compensation, it's only about 4 minutes. It took only 4 minutes until he reaches the next stage, which is alright, but as to improve is what Christoph said. He has to be doing these exercises, he has to give it to his fitness coach, and from there, he has to work, for example, maybe 2 minutes and then break, and then 2 minutes and break, and then slowly it will improve.
The athlete can also improve his aerobic capacity by working with heart rates instead of speed. You can use the heart rate. You can see here the heart rate. LT was 169, RC 185. You can work the ratios to let's say 2 minutes in 169 beats per minute, then another 2 minutes interval training on 185 beats per minute. So you can improve that. That is where you're gonna see that you will be able to run faster, and then you have more aerobic capacity, so you can run for longer as well.
Alright, I think the athletes, there is nothing else to worry about. They have his result, they have his measurement. Now the only thing that is left, hard work, improve yourself, keep going, best for you.
Well done.
That's it.